Good day, everyone. This is Dr. Soper here, and today we'll be discussing cell referencing and basic what-if analyses in Microsoft Excel. Let's begin by taking a look at the three major topics that we will address in this video. To begin, we'll learn about the different methods that can be used to reference cells on an Excel worksheet. After that, we'll take a few moments to ensure that we understand the difference between functions and formulas in Microsoft Excel. After reviewing those two preliminary topics, we will be well prepared to learn how to conduct a basic what-if analysis using Microsoft Excel. In order to facilitate our discussion, we will be using Excel to perform a what-if analysis for the owner of a dance club. Specifically, the owner has asked us to determine the entrance fee that she should charge customers in order to maximize the yearly net income generated by her dance club. Now that we know what lies ahead, let's get started. Excel provides us with three different methods of referencing cells within our worksheet formulas. These methods are known as relative cell referencing, absolute cell referencing, and mixed cell referencing. Let's see examples of each of these methods. Imagine that on this simple worksheet, we want to add together the price of a menu item along with its associated amount of tax in order to determine the total price that should be charged for the item. Using the delicious nachos as an example, we could accomplish this task by first clicking on cell D4, where we want the total to appear, typing the equal sign in order to tell Excel that we want it to calculate the value that will be displayed in the cell, and then typing B4 plus C4 in order to tell Excel that we want it to add together the values contained in cells B4 and C4. After pressing the Enter key, Excel performs our requested calculation and displays the resulting total in cell D4. At this point, if we were to select cell D4 and use the fill handle to drag our calculation down to cells D5 and D6, we would see that Excel has correctly calculated the totals for the menu items appearing in rows 5 and 6 on our worksheet. The reason that these calculations are correct is that, by default, Excel uses what is known as relative cell referencing whenever we copy a formula from one cell to the next. Put another way, Excel is aware of the relative positions of the cells whose values we are manipulating, and it automatically updates cell references accordingly. Recall that in cell D4, we instructed Excel to add together the values of cells B4 and C4. If we moved to cell D5, we will see that Excel has automatically updated the cell references such that the value displayed in cell D5 is the result of adding together the values of cells B5 and C5. Excel has similarly updated the row numbers for the calculation in cell D6. Again, this behavior is known as relative cell referencing. As a brief aside, you may have also noticed that Excel automatically formatted our results using the accounting number format. We could easily change this if we wanted to by using the number format drop-down box. However, in this case, the accounting number format seems appropriate for our purposes. Although relative cell referencing can be very useful, there are often times when we do not want Excel to behave in this way. For example, imagine that instead of providing the specific amount of tax for each menu item, we instead wanted Excel to calculate the proper amount of tax for us given a particular tax rate. In this case, let's say that our tax rate is 7.5%. I think I will also use the percent formatting style in order to make our tax rate look a bit better, and I will also increase the number of decimal places to 2. Next, let's delete all of the existing values in our tax column since we want Excel to calculate these values for us based on the tax rate. Moving to cell C4, I can tell Excel to calculate the amount of tax for the delicious nachos by entering the formula equals B4 times B1, where cell B4 contains the price of the nachos, and cell B1 contains our desired tax rate. When I press the Enter key, we can see that Excel has correctly calculated the tax for the delicious nachos. But if I use the fill handle to drag that calculation down to cells C5 and C6, we can see that Excel has not calculated the correct results for these two cells. As you may have guessed, the reason for this is that Excel is using relative cell referencing. Therefore, instead of using the tax rate value in cell B1, Excel attempted to use the values in cells B2 and B3 when performing the tax calculations for cells C4 and C5. In order to fix this problem, we can use what is known as absolute cell referencing. When we use absolute cell referencing, we are explicitly instructing Excel not to update the row numbers or column letters in a cell reference when we copy a formula from one cell to the next. In our current example, we could tell Excel to use absolute cell referencing by clicking on cell C4 and then selecting the reference to the tax rate in cell B1 within the formula. By then pressing the F4 key once, we can see that Excel adds a $ in front of the column letter and the row number. A $ in front of the column letter tells Excel not to automatically update the column letter when we copy and paste the formula, while a $ in front of the row number tells Excel not to automatically update the row number when we copy and paste the formula. After implementing absolute cell referencing for our tax calculation formula, if we now copy the formula to cells C5 and C6, we will see that Excel now performs the calculations correctly, since it is multiplying the fixed tax rate by the price of the current menu item. Note also that if we now change the fixed tax rate, the amount of tax for each item and the associated total price of each item will be updated automatically. Now that we're familiar with relative and absolute cell referencing, we can take a look at mixed cell referencing. When we use mixed cell referencing, we are telling Excel to either hold the column letters constant but automatically update the row numbers when we copy and paste cells, or to hold the row numbers constant but automatically update the column letters when we copy and paste cells. As an example of this, imagine that we have a grid of 9 numbers arranged into 3 rows and 3 columns. I'll use the Borders drop-down box to draw a border around this grid of numbers. Next, I'll use the sum function to add together 2 neighboring cells. Before I press the Enter key, however, I'll select the reference cells and press the F4 key twice. As you can see, there is now a $ in front of the row number component of the cell reference, but not in front of the column letter component of the cell reference. We are therefore instructing Excel to automatically update column letters when our function is copied and pasted, but to hold the row numbers constant. As I drag the formula from one row to the next, you will see that the result of the calculation does not change, because Excel is holding the row numbers constant. If, however, I drag a formula from one column to the next, you will see that the result of the calculation changes, because Excel is automatically updating the column letters. This is one example of mixed cell referencing. In the other type of mixed cell referencing, Excel will hold the column letters constant, but will automatically update the row numbers. If, for example, I update the input range inside of the sum function, such that the $ appears in front of the column letter, but not the row number, we will see that the result of the calculation changes when we copy the function from one row to the next, but the results do not change when we copy the function from one column to the next. Again, this behavior is known as mixed cell referencing. Now that we have a good understanding of the various types of cell referencing, let's learn about the difference between functions and formulas in Microsoft Excel. Put simply, formulas are user-defined expressions that calculate the value displayed in a cell, while functions are predefined tools that use specific inputs in order to calculate the value displayed in a cell. Returning to our previous example, when we were entering the equations to calculate the amount of tax and the corresponding total for each menu item, we were writing formulas because we were defining the equations ourselves. Later, when we were demonstrating mixed cell referencing, we were using a function, specifically the sum function, which is a predefined tool provided by Excel whose sole purpose is to add numbers together and return the result. Remember, functions are predefined components, while formulas are user-defined. Also note that it is possible for a formula to contain one or more functions. For example, if we wanted to know the difference between our highest priced item and our lowest priced item, we could simply write a formula which returns the result of the min function subtracted from the max function. In this case, we see that this difference is $3.55. Now that we've reviewed cell referencing and the difference between functions and formulas, we should be well prepared to conduct a what-if analysis. Generally speaking, a what-if analysis is a very useful tool which allows a person to understand how changing one or more input values will affect the outcome of a particular scenario. What-if analyses are very useful for answering questions, identifying goals, and helping people to make decisions. If you recall from the beginning of the video, we will be conducting a what-if analysis on behalf of the owner of a dance club. In this particular scenario, the owner has asked us to identify the entrance fee that she should charge in order to maximize her yearly net income. As we can see on this Excel worksheet, the owner has provided us with some information about her dance club. Specifically, we are told that on average, each customer spends $23 on food and drinks. We are also told that the dance club's fixed costs for things such as rent and maintenance amount to $32,000 per week. The average costs that the dance club incurs for each customer are $15.50, and the total effective tax rate that the dance club pays for federal, state, and local taxes is 35% of its earnings. The owner has also noticed that the average number of customers who visit her dance club per night depends on the entrance fee. Specifically, the average number of customers is equal to 500 minus the quantity 20 times the entrance fee in dollars. Thus, if the owner charges no entrance fee, the dance club will get an average of 500 customers per night. If the entrance fee is $10, the dance club will get an average of 300 customers per night. And if the entrance fee is $25 or above, no customers will come to the dance club. Using only this information, we will be able to perform a what-if analysis in Excel that will allow us to identify the entrance fee which will maximize the owner's yearly net income. Before we begin our what-if analysis, let's format the appearance of our worksheet to make it a bit more attractive. First, I will use the today function to automatically fill in the date of the analysis. We could also use the now function if we wanted Excel to provide us with the time in addition to the date. For our purposes, however, the today function should be sufficient. I will also use the number format drop-down box in order to format the date value, and I will right indent the value just to make it appear a little cleaner. Next, let's insert some rows in order to separate all of the parameters into categories. To insert a row, you simply need to right-click on the row above which you would like the new row to appear, and then select Insert from the menu. I will also change the background color of these new rows in order to better visually separate the parameters. Next, let's insert a new column that we can use to label our parameter categories. After right-clicking to insert the new column, I will add a few labels in order to help us identify the various parameter categories on the worksheet. As you can see, we have now divided the parameters into constants, revenue data, cost data, and income data. Now let's write some formulas to calculate the missing values on the worksheet. To begin, we know that the average revenue per customer will be equal to the entrance fee plus the average amount of food and drink spending per customer. I will therefore enter the formula equals C7 plus C2 into cell C8. I will also press the F4 key once to ensure that Excel uses an absolute cell reference for the average amount of food and drink spending per customer. That way, if I copy the revenue per customer cell, Excel will continue to use the correct amount for the average food and drink spending per customer. Next, we know that the total revenue per night will be the product of the number of customers per night and the average revenue per customer. We can therefore write a formula that multiplies cells C8 and C9 together in order to calculate the total revenue per night. Given that there are 7 days in a week, the average number of customers per week will simply be the average number of customers per night multiplied by 7. Similarly, the total revenue per week will be equal to the average daily revenue multiplied by 7. The dance club's weekly variable costs can be easily calculated by multiplying the club's costs per customer by the number of customers per week. Next, we can calculate the dance club's total weekly costs by adding its weekly fixed costs to its weekly variable costs. To determine the dance club's weekly earnings before taxes, all we need to do is subtract the total weekly costs from the total weekly revenues. Calculating the club's weekly taxes is a bit trickier, since taxes will only be paid if the club's earnings are positive. In order to handle this issue, we can use Excel's if function. The if function performs a logical test and returns one value if the test is true and another value if the test is false. In our case, we want to test whether the club's earnings are greater than 0. If the answer is yes, then we can calculate the club's taxes as the product of its earnings and its effective tax rate. If the answer is no, however, then the club taxes will be 0. Now that we've calculated the club's taxes, we can next determine the club's weekly net income by simply subtracting its taxes from its earnings. Finally, given that there are 52 weeks in a year, we can easily calculate the dance club's yearly net income by multiplying its weekly net income by 52. At this point, we can conduct a simple what-if analysis by playing with the value of the entrance fee. For example, when the entrance fee is $0, we can see that the club will lose almost $300,000 per year. As we incrementally increase the entrance fee, we can see that the dance club becomes profitable when the entrance fee reaches $3. But what is the optimal entrance fee? Put another way, what is the entrance fee that will maximize the yearly net income for the dance club? To answer this question, let's use the columns to the right to test the effects of increasing the entrance fee by $1 at a time. In this case, we have enough room to test entrance fees between $3 and $11 without needing to scroll our worksheet. Since we used absolute cell referencing for all of the constants in our formulas, we can now simply copy all of the formulas in column C and paste them into columns D through K. Examining the yearly net income row, we can see that the club's yearly net income increases as the entrance fee increases from $3 to $9, after which the yearly income begins to decline. Based on the results of this what-if analysis, we can now recommend to the club owner that she charge a $9 entrance fee in order to maximize her yearly net income. Further, now that we have all of the calculations in place, we can easily see what would happen if other values besides the entrance fee were to change. For example, if the owner of the dance club were able to find a way of increasing the average food and drink spending per customer from $23 to $26, then our what-if analysis reveals that the dance club would maximize its yearly net income by charging an entrance fee of just $7 instead of $9. As you can see, what-if analyses can be very powerful tools for decision making. Well, my friends, thus ends our overview of cell referencing and what-if analyses in Microsoft Excel. I hope that you learned something interesting in this video, and until next time, have a great day.